Okay. So, what do we have any notes left in the batch we gave you the other day? On Wednesday, or did we get through all? You got through all of it? Awesome. Perfect. Okay, so that's due on Monday by 3 o'clock. The worksheet that went along with that. So that's good. So now we can start the next section. Feels a little more out. You're welcome. Did you get my email back?
I did.
Okay, the email I sent back today. I sent you a picture of what it's looking like on my end.
Okay.
You can look at it before you leave.
Okay.
You just may not have attached it correctly or whatever.
Okay.
Because it's not showing me it.
Okay. I'll go.
Okay. You're welcome. Yep. All right, so this is what we're looking at next. Now for simplifying using factoring skills. All right, now for simplifying using factoring skills. When a problem asks you to simplify, number one, factor out GCF. Number two, factor like you did polynomials by using trig functions. Oops, hold on. Using trig functions and variables. All right. Now, just like the unit circle, all right, everybody learns things differently. So if you need to write this down or you can develop it, it's completely up to you on how you do it. All right. All right, just clean up a little bit. All right. So here's the idea. So this is the identity you wrote down the other day. Sine squared x plus cosine squared x equals 1. All right. Well, that's going to appear in many different ways. All right. Because basically we're simplifying. We're trying to make things smaller rather than trying to evaluate expressions. So in other words, this can show up like this. Sine squared x equals 1 minus cosine squared x. Cosine squared x equals 1 minus sine squared x. All right. So you know when you see an expression 1 minus cosine squared x, it equals a sine squared x. All right. The second part of that is this. All right. If we make it negative, so negative sine squared x equals the negative of 1 minus cosine squared x. All right. Well, that makes the negative sine squared x. The negative of the 1 makes that negative 1, but the negative of the negative cosine squared x turns that into cosine squared x. So whenever you see either sine squared x minus 1 or cosine squared x minus 1, that's the negative of the other one. Okay, that's the negative of the other one. All right. So you can choose to do it two ways. You can either A, all right, you can look at this and derive it. All right, you can look at that and derive it from that. All right, or you can memorize all these features about it. It's completely up to you. All right, but what goes into your notes is a separate note on the Pythagorean identity. And that is that sine squared plus cosine squared u equals 1. Sine squared equals 1 minus cosine squared u. All right, so sine squared equals 1 minus cosine squared. For the same reason, cosine squared equals 1 minus sine squared. All right. Cosine squared u equals 1 minus sine squared u. All right. And then the appendage is 1 minus sine squared equals negative sine squared minus 1. Oops, didn't want to do that. So there you go. So if we're looking at the first one, sine x cosine squared x minus sine x. All right. The first thing we want to identify is that they both have a sine, so we pull that out. So we pull that out. So whenever we have multiple things, if they have something in common, we pull that out. In this case, sine x. And then what you want to identify is cosine squared x minus 1 is the same thing as negative 1 times 1 minus cosine squared x. Eventually, hopefully, you can get to the point where you can do it without factoring the negative 1 and then just recognize that that's equivalent to negative sine x times sine squared x. And then at the end of the day, we have negative sine cubed x. So we're trying to make it written with as few trigonometric terms as possible. That is our goal. All right. The one on the right, secant squared minus 1. All right, the one on the right, secant squared minus 1. Okay. Tangent squared plus 1 equals secant squared x. So basically, if I could get that 1 onto the other side, tangent squared equals secant squared minus 1. And you can identify that that and that are exactly the same. So that would be rewritten as tangent squared x. And you're done. Okay? Now, when you come to one where 1 is squared and 1 is not, but they are the same, all right, you're going to factor this like a quadratic. Now, if it's easier for you, you can replace the tangent theta with x. So x equals tangent of theta. So instead of that with the trig, it's now 4x squared plus x minus 3. Just keep in mind that x is equivalent to tangent of theta. All right, that factors, if you're going to use slide and divide, to x squared plus x minus 12, which is x plus 4, x minus 3. And then please, oh please don't forget, you need to bring back the original lead coefficient, which is 4. You put that under your constants. When it goes in evenly, you divide. 4 divided by 4 is 1, so that would be x plus 1. When it doesn't go in evenly, you bring it up to the top. That would be 4x minus 3. And then your last step is to go back and substitute back in what x represented. Since x represented tangent theta, it's tangent theta plus 1 or tangent theta minus 3. All right. Question. All right, so give those 3 a whirl, please. Give those 3 on the top of the next page a whirl. See how we do with it.
Pardon the interruption. Would you please send Alessandro Triola to attendance office at the end of the period?
Absolutely.
Thank you.
You're welcome. I guess that'll be you.
Yeah.